everybody. In this video, what I'm going to do is I'm going to introduce the notion of our next rule conditional proof, or arrow in. Let's get into it.
So remember, for doing the proofs, we have three moves in place. We have the arrow out, which again, the question I said with that is, can you do that? Then do it. We have the and out. The question there is, if you got a dot that's not in parentheses, break it apart. And then we got the and in. If you got more than two things, you can always put them together, but the question is, should I do that? Those are the three rules that we have in place. There's one more rule that we need to talk about, and this one's a little bit different from these. These are all rules of inference here. We take something and we make something else out of it based on what we've got. This next one here is a little bit different from that. But let's see when we need to use it first. Find ourselves in a situation that things get very heated very quickly. So let's take a look at this argument. Let's say we had this. I got C arrow R, that's an assumption. R arrow M, that's an assumption. I've got M arrow B, that's an assumption. And let's just say here I want to solve for C arrow B. Okay, that's the situation. Given that, what do I do from here? Well, here's our list. Okay, so we're going to start with this. Arrow out. Do I have any arrows not in parentheses? Actually, I have a ton. Let me go ahead and label these with their numbers too. I have a ton. I have one in line 1. I have one in line 2. And I have one in line 3. Okay, arrows not in parentheses. Now, do I have any left side matches? Nope, there's no C by itself somewhere. Nope, there's no R by itself somewhere. Nope, there's no M by itself somewhere. So no, I cannot do any arrow outs. Don't despair, there's another rule here. Can I do an and out? Do I have any dots here, not in parentheses? Well, in fact, not only do I not have any dots not in parentheses, I don't have any ands here, period. This is all conditionals. There are no conjunctions. Then the question becomes, should I put any two lines together? Now, we can put any of these two lines together. In fact, one looks kind of close. We might say, hey, we could put C arrow R, and we could put M arrow B together, and then look, at least this one's got a C and a B in it. That's basically the same thing as this, right? And I could say and in 1 and 3. You can totally do that. This is not wrong to do. That's not the correct answer. It doesn't get you. This is not the same thing as this, because there's an R and an M here that aren't here. So that's not correct. There's nothing wrong with that move. It doesn't complete it. So look, we did it all. Arrow out, and in. Well, shit, what do I do now? Well, this actually is what we do. This leads us to the next rule that we need to use. And the rule that we're going to use here is actually a theorem, which means we use it only in special situations. So I think of, the other ones that we've used so far, these are like almost like for everyday use. This is something that you might use every day, like a toothbrush or deodorant. Whereas this next we're going to use, it's more like a fire extinguisher. Probably something that you don't use every day, but you use it in very specific situations. So this is one. So what are the features of the situation going on here? Well, one, you can't do any of these, or they don't go anywhere. Like, we can do the third one, but it doesn't lead us anywhere. So that's the first feature here. The second feature is that what I need to look for is my goal, the thing I'm trying to solve for, or the thing I'm after at the moment, is it an arrow? Yes, it is. Look at it. There it is in all its glory. It's an arrow. If it's true that you can't do anything, okay, that leads anywhere, like again, we can do this one, but it's not efficacious. If that's true, that we can't do anything efficaciously, and our goal is an arrow, we actually have a way out. And this move is called conditional proof, or arrow in. Here's how arrow in works. Here's what you do. Think of it as like a side quest or a subplot to what's going on here. We play it's like a mini game inside the proof that we're doing. So what we do is this. Provisionally assume the left side of the goal. Okay? And then you get the right side. Now, what do I mean by provisionally assume? Well, our assumptions are what we started with. Provisionally assume means, let's just play pretend here for a moment, and just pretend that the left side of the arrow is true. And let's just see if we can get the right side. Now, the way arrows work is, if something's true, and you can prove that something follows, then the arrow is a true arrow, which means this is real, and you actually prove this. So in other words, you can prove the whole arrow, the thing that we're actually after, if by seeing if this thing were by itself, does it actually lead to this thing? So like I said, though, we're going to think of it as like a mini game or as a side quest. So how do we provisionally assume? So here's what I'm going to do here. Whenever we provisionally assume anything, and there are only two situations, this is literally 50% of all the times you're going to have to provisionally assume in this course. It's either this situation or one other situation that we're going to talk about on the next quiz. Okay, here's what you do. Okay, we get stuck here. So again, here's the scenario. We're stuck. Nope. Nope. Yeah, but it doesn't lead anywhere. Okay, do this. And I indent whenever I do a provisional assumption. So I'm going to say line 4 here. What does it say to do? Provisionally assume the left side of the goal. What's the goal? What we're trying to solve for, C arrow B. So I'm just going to provisionally assume the left side. So I'm going to stick, what's the left side? C. And I'm just going to say provisional assumption, which means it wasn't an original assumption. You could almost think of it as like pretend assumption. Like, let's just play pretend here and see if this works. In order to get, like, the mission was, okay, get the right side of the goal. So we're saying, if this works, will it lead to this? So I'm going to just put a little tag here saying, all right, the mission right now is get that right side. Do it. Okay. So with this provisional in place, and like I said, we're just going to say, let's see if this just works. The mission right now is not really this. It's get this. The mission right now, the side quest, the subplot, technically the sub-proof. Get this thing, get this thing, get this thing. Think about nothing else. With that being said, what we do is now, with this thing, let's just say we can play with this one too, go back to the regular order of business. Can I do an arrow out? Can I do an and out? Should I do an and in? Let's take a look and find out. So those arrows haven't changed. They're still here. Do I have a left side match now with this thing here? I do. Line 1 is C arrow R. I've got a C now. What does that unlock? And line 5 I can say, oh, I get R. What do I do there? Arrow out, 1 and 4. Okay, now we're going places. Now with the R here, do I have a left side match? I do. With line 2, that unlocks the M. I can say there, how'd I get that one? Arrow out, 2 and 5. And now with the M here, what do I get? Is there a left side match here? Yep, between 3 and 6, and gets me B. Arrow out, 3 and 6. Now, think back. When I started this side quest here, I said, I'm going to pretend like C works, and I'm going to see, can I get B? I did. So what I'm going to do here is I'm going to basically draw a little line here along the side, and I'm going to go, side quest is complete. If you start with a C, you will get a B, which means this arrow is true. If C happens, then B will eventually happen. Here it is. You can see it happen eventually. So what I'm going to do here is, this is like the side quest that I indented on. You don't have to indent. I just do it so I can see it right there. But then what I'm going to do is I'm going to zoom back out here in line 8, and I'm going to say, yep, C arrow B is a thing. Okay, yeah, if you got C, it'll lead to B. Now here, this is an arrow in. So we say, yeah, it happened. Now here's what's different. For this one, the numbers are, you're going to cite where did you start the side quest all the way to where did it stop. So in other words, where did it start? It started at line 4 when we provisionally assumed the left side. Where did it end when we finally got the right side? 7. So this is arrow in 4 through 7. So this is an arrow in. Arrow in is my nickname for a conditional proof. I guarantee you that you did these in geometry. I remember doing these in geometry in 10th grade, or at least I remember doing something called a conditional proof, having no idea what was going on. This is what it is. Basically, you just prove an arrow. You say, oh, a conditional statement, it works. Let's say you had a triangle. This angle is 45 degrees. Another angle is 45 degrees. Then you know that the next angle is going to be a right angle, because what's going on there? All the angles in a triangle add up to 180 degrees. So if you had a 45 degree angle and a 45 degree angle, then you know the other one's going to be 90. You can do that as a conditional proof. You can prove it. That's a geometric one. We're not going to do any with geometry or stuff like that in here. But this is our first example of a conditional proof for an arrow in. Again, what you do when you get stuck, first thing is my goal and arrow. If the answer is yes, pop the left side in there and try and get the right. Once you do that, you can say, yep, an arrow totally belongs in there. We can prove it conditionally. All right, let's take a look at another example with this. Let's say I've got A arrow B. That's assumption number 1. Let's say I've got B arrow C. That's assumption number 2. And then I'm just going to say, all right, get A arrow C. Now later we'll actually learn a move that'll solve this in one move. We're not quite there yet, so hopefully you can see, like, if A leads to B and B leads to C, it's almost like cars on a train. If A, like, this is like, if Sunday is before Monday and Monday is before Tuesday, then Sunday is before Tuesday, like something like that. Like, well, then I can cut out the middleman, so to speak. The B is just like a middle term that I can just make A go straight to C. Yep, we're gonna get there, but that's a move that we'll learn how to do that in one move later. Right now, we're working on what to do with the moves that we've learned so far. So that can be defeated by other means later on. That's something that we haven't learned yet. That's something you can unlock later in the semester. Let's take a look at these. First of all, arrow out. Do I have any arrows not in parentheses? Yep, both of them. These are arrows, not in parentheses. Left side match? Nope. Left side match? Nope. Moving on. Do I have any dots, ands, not in parentheses? Nope, not today. Should I make an and in here? I can. Okay, I could make A arrow B and B arrow C, but that's not this. All right, so I can do that, but it doesn't lead anywhere. So, are we stuck where we can't do any of the others with any kind of efficacy? Yep, well, then in this situation, here's what we do. First of all, is our goal an arrow? Yep, the goal is in fact an arrow. Okay, when you're in the situation, you start a side quest, okay, a little side mission. So what you do here is you provisionally assume the left side. So what we're going to do is we're going to provisionally assume this, okay, and then we're going to get or solve this. Get this, okay. You do that, then you can stick the arrow between. You can say this arrow is true. So if you plug this thing in and you get this result, then this works. If this happens, this really will happen. Okay, so you're proving that it works. That's what you're doing. You're basically proving that the conditional really is true. Like, if this thing happens, then this other thing will happen. So let's take a look at this. So that means line 3 here, and whenever I start one of these side quests or provisional assumptions, I indent preference amount. So I'm going to stick this A here, and I'm going to say this is a provisional assumption. It wasn't one of the originals. It's one that we're just playing pretend with it and seeing if it works. Okay, and then this is a provisional assumption with the following quest line. So here's the goal, here's the mission. Get C by itself. We do that, we can plug the arrow in there, and our work here is done. Now with this A plugged in, we go back to the regular order of business. Can we do this stuff? So now with this A here, can we do an arrow out? Yep, there's this arrow. Now this new A here is a left side match, which gets us B. Arrow out, 1 and 3. This B actually is the left side match for this line 2, which will get us C. Arrow out. The arrow was in 2. The left side match was in line 4. And by the way, this C we just got, that's the thing that we set off to get. We just got it. So side quest complete. Okay, we did it. Now, what will happen sometimes is people will say, I did it, and they'll stop right here. You finished the side quest, you didn't finish the main quest. Okay, so what you do after this happens is we need to zoom out and say what we did. So let's zoom back out into the main quest and say, all right, what this does here is we want to say, yep, A arrow C, our side quest proved that this is actually a thing. If you want to, even when I draw this line, when I indent here, if you want to stick a little arrow, make it like this, like you're saying you can stick the arrow in here. If you want to do that, that's fine. So what we're saying is here that, yeah, A arrow C, it's totally a thing. The arrow in there is legitimate. It works. And then you say, where did it start? Hey, we started trying to prove it in line 3. Where do we prove the end of it? Line 5, when we got the right side. Now, this proof is done. So let's take a look at another practice problem where things get a little bit tricky, where it looks tricky. It's actually no more complicated than what we're doing here so far. In reality, it's just going to feel like it's more complicated. So we've got A and B. So this is our first one now. We've got the and in it too. A and B, arrow C. Okay, that is our one and only assumption. And then we're going to get if A, then if B, then C. A arrow, B arrow, C. Actually, later on in the semester, again, like towards the end, you'll learn that these actually, you can switch between them. They're actually kind of saying the same thing. Well, obviously, if you can lead from one to the other like this, but actually, they kind of work vice versa. That's something you'll see later on. Like right now, that's not obvious. Okay, so what we want to do is, based on what we know, we want to see if we can get from this to this. Now, it's possible. But let's do it by what we've got here. Do we have any arrows not in parentheses? Yep. We do, right there. Left side match. The left side is A dot B. Do I have that? I do not. So I'm not getting that C out. That's not happening. Do I have any dots not in parentheses? I have a dot, but it's in parentheses, so that's locked. I can't touch that for now. Can I do an and in? And remember, the question there is, should I? Well, not only I shan't, but I can't, because there's nothing else to and in with. So here, it's not even a matter of Should. I cannot because there's only one thing. You need at least two things to do an and in. So no, no, no. So, of course, what do I do here? Well, is my goal an arrow? Yes. But the arrow, again, that's in question is the one not in parentheses. There are two arrows up here if you're just looking at it. But my goal, the arrow here is actually this one. The right side of this arrow just happens to also be an arrow. So this is the goal that I'm looking at. This is the statement. This is the conditional statement here. There's its left. So its left side is this. So we're going to end up PAing this. And we want to solve for this. Okay? We want to get this. So what I'm going to go ahead and do here is I'm going to put here, I'm going to start this side quest. I'm going to say, okay, line 2. Okay? We're going to take A, and we're going to provisionally assume it. And the mission is get the right side of the arrow, which is just B arrow C. It's a little bit bigger, but that's the mission. Get B arrow C. Okay, with this in play now, can I do an arrow out? Nope, this is only half of a left side match. Not all of it. And out. Can I break anything apart? Again, that dot is still in parentheses, so it is unbreakable right now. Now, this time, can I do an and in? I sure can. Should I? Nope. Doesn't get me anywhere. Well, now it looks like we're stuck again. Well, what do we do now? Don't panic. Think about the situation. Is our goal right now an arrow? What is our goal right now? Our goal right now, yeah, we're trying to get this at the end of the day, but our goal right now in this side quest is actually this. B arrow C. So if you're stuck, you can't do anything else. What do? Start a new side quest. So here, we're in a side quest and a side quest. So that means, look here, all we're going to do here is inside our side quest, we're going to PA this, and we're going to try and get this. And if that works, then we're good. If this doesn't work, this problem's not doable. Because based on what we know, there's nothing else we could do. Well, let's see. Can we PA the left side of this arrow and get this thing? Let's try it. So I'm going to say here, line 3, a new indentation for a new side quest. B, and this is a provisional assumption. Here, I'm trying to get just C by itself. Now, if I can do this, with the B here plugged in and I get C, then I can say B arrow C is the thing. Okay, so that's what I'm worrying about right now. Now, if I can get that, if I get B arrow C, then I'll prove that A arrow B arrow C is a thing. But let's one step at a time. So here, now with this B here, let's see, now, can I go anywhere? Can I do an arrow out? No. The left side of this arrow still is A dot B. Now, do I have A dot B? No. Now, you might see right now, I actually have the pieces, but I don't have it like this. So let's just walk through the numbers to make sure we're just doing it this consistently, like always going through this process. Do I have any dots I can break apart right now? No. Do I have anything I should put together? Yes. Finally, I do. Because look, the left side of this arrow, remember, look for, first of all, is my goal a dot? No. Second thing you want to look for, left side's my arrows, any of them dots? Yep. Do I have the pieces to build that? Do I have the pieces to build A and B? Yeah, literally, there they are. Put them together then. Watch this, so I'm going to go A dot B. Now that move, and in, I feel like we haven't done one of those in a while. Lines 2 and 3. So now I've built it. Now can I do an arrow out? Yep, because I just made the left side match. Manufactured it for my own uses. That unlocks this C. Let's go ahead and do that. We get C. What move there? Arrow out. 1 and 4. Now check it out. In this side quest, I said I was going to go after B. I was going to just pretend, see if B works. Can I get C? I did it. There it is. B leads to C. So then I'm going to zoom out of this side quest, our side quest, into our side quest. And I'm going to say, hey, I proved it. If you start with this, it will lead to this. That means B arrow C is a thing. How? How did I prove that? With this thing. Arrow in. Where did it start? Line 3. Where did it stop? Line 5. That's where we got where we PA'd the left side, where we got the right side. So this checks out. Okay? It checks out. Now, here, in doing this now, I actually completed just the plain old side quest. Look, here, remember, way a long time ago, I had provisionally assumed A in order to get B arrow C. I just got it. So here, the way this works when you have one inside another one, usually it works like dominoes. Like, actually, once we got to this part, the whole rest of the thing is just going to just knock down, everything works out. So check it out. Here, I actually fulfilled this side quest. Look, A, you start with A, it actually leads to B arrow C. Side quest complete. Which means here I zoom out back into, so to speak, the main quest. And I can say here, yep, took a while. But if you start with A, you will actually get B arrow C. Look, that's the goal that we wanted. Now, how did it happen? Here, it's this. We did an arrow in there. You can actually stick an arrow in between this thing and this thing. Where did this one start? This one we actually we made the provisional assumption of A in line 2. Where did it stop? Well, we got the right side in line 6. So 2 through 6. Bam. So this one, there was I've been saying side quest, but it's a subproof inside a subproof inside a proof. But even when we got stuck right here, we still only use one of these 4 things. Still, all of the problems here on this quiz, really, there's no more. This is it. This, arrow out, and in, or in emergency situations needing the arrow in. Now, since we're first learning the arrow in, there'll be plenty of those because we're learning this when it's new. But it's a theorem. It's sort of like for emergency use only. It's not a rule of substitution. Certain conditions have to, that's why it's conditional proof, certain conditions have to be met to even use it. That's what makes it a theorem instead of just a regular rule. So let's take a look at another proof now. All right, another practice one, and then we'll get into some more of the problems that are in the pages of the book too. This one's actually very similar to the last one, but just in reverse. It actually ends up being less complicated. All right, so let's go ahead and start it here. Now I've also condensed my list a little bit. You can refer to the basic rules of formal logic if you want a more detailed set of what these things do. But just to save myself some room here on the screen and on this board, I'm going to just make this a little bit like a shorthand. When we need to employ them, I'll remind us of what's going on. But that'll just save me a little bit of space here, now that we've been doing this for a little while. So let's start with this one. This one, all right, again, first thing to do, arrow out. First of all, do I have any arrows not in parentheses? This one. Okay. Do I have a left side match, though? Nope, because this is only one assumption. So no. Moving on. Do I have any dots not in parentheses? No. Moving on. Do I have any anything that I can and should put together? Not only shouldn't I can't put anything together because I only have one line. So in this situation, what do? First of all, we look and see, is our goal an arrow? Well, of course it is. There it is. Later on, we will find situations where that doesn't happen. It's not an arrow, and we have to do something else. We're not there yet. That won't happen on this quiz. So yeah, our goal is an arrow. So what do we do in this situation? We provisionally assume the left, which this time is a little bit heftier, and we're going to want to get the right in a side quest. Let's do that. So let's indent a level, begin our side quest. So we're going to provisionally assume the left side of the arrow of our goal. That's A and B. That's a provisional assumption. But the mission here in the side quest is to get the right side, which is C. So get that, and then we can stick the arrow in there. And then we're actually going to be good. All right, so let's do it. Now, with this dot here, can we do an arrow out? No. Okay, the stuff is together. Now look, do we have any new dots not in parentheses? Yes, we do. Right there. So what can we do to those? Whenever you see a dot not in parentheses, slice it right in half. And that gets you some new bits. We get A and B separately. But how? And out on line 2 for both. Cool. Now go back to the top of the list. Can I do an arrow out now? Do I have a left side match now? Yup. This left side match is going to unlock this right side of the arrow right here. So that gets me in line 5. B arrow C, which has now itself been freed from the parentheses. Again, where's the arrow? The arrow was in line 1. Where's its left side match? Line 3. And look, this is like teed up perfectly for us. Take a look. Go back to the top of the list just to make sure. Do I have any new arrows not in parentheses? This one. Does it have a left side match? Literally right next to it. What does that do? That unlocks the right side, which is C. What move did I use there? Arrow out. Okay, where was the arrow? Line 5. Where was its left side match? Line 4. And look, that's what we set out to do. We said we were gonna try. If we got A dot B, will we get C? Oh yes, we will. So now I can say side quest complete. So now I'm going to zoom out here, back into the real world, main quest, and I'm going to say, yeah, this is totally a thing. If you start with A dot B, because this is literally what a conditional proof is saying. If you start with this, then, that means here's the arrow, then you will get this. Well, how do I know that? Prove it. That's what this is. If you start with this, then you will get this. This is just the shorthand of saying this. Where did this happen? We want to show our receipts. That was arrow in. Where did this start? Where did we provisionally assume the left? Line 2. Where did we get the right? Line 6. And this problem is now complete. Okay, let's take a look at this one. This one we got A arrow, B arrow C. That's our one and only assumption, and we're going to go after B arrow, A arrow C. Okay, a lot of the same letters. It looks like they're just kind of mixed up, but remember, They're all arrows. It's not dots. So if there were dots, there's a way we could break these apart very easily and just move them around. Not what's going on here. It's all arrows. Let's see. Does this one lead to this? So first of all, we have any arrows not in parentheses? Yeah. Left side match? We can't because we only got one item. Any dots in here? Not at all. Anything to put together? No. So, and this has been a pattern here so far at this point. Is our goal an arrow? Yes. So what are we going to do? We're going to PA this, and we're on a mission to get this. Okay, let's try it. So indent a level. Start our side quest. We're going to say, all right, let's pretend that B works, and then we're going to go on a mission to get A arrow C. Cool. Now, with that in play, let's try it. Can we do an arrow out? No. You might be thinking, hey, it's the left side of this arrow. That was in parentheses. It doesn't work. Can I do an and out? Nope. No dots. Still. Can I do an and in? I can. Does it go anywhere? No. Remember, what's the goal right now? The goal right now in the side quest is A arrow C. So ask this question. Is my goal an arrow? This is my goal right now. So yes, it is. Alright, so in this situation, what we do, we're going to start another side quest. We're going to PA this thing. And we're going to go and get this thing. Alright, so that's going to be the mission right now. We're going to PA the left of our goal. So the left side of our goal right now. New side quest. Side quest. This is our new provisional assumption. And the mission for this side quest is get the right side there, which is just C. So right now we get C. Now, the way these work though, like I know it seems more complicated when you have like one inside another one inside the main one. But actually, once you get this, the first thing, everything else, like I said, it's like a domino effect. Everything else is just smoothly lines up right after that. So let's go on a quest after this now. We get C, everything else will just unravel from there in a good way. So now with this A here, now can I finally do anything? Can I do an arrow out? Yep, finally. There it is. There's a left side match. Now it's in 3 layers deep, but here it is. Also, I'll just say this at this point. Maybe I should have said this earlier. If you look at any of these proofs online, like if you Google some stuff on logic, a lot of logicians make it that when you start one of these subproofs or side quests, that you have to copy and paste the stuff that's on the outside inside the other ones. And that's a rule called reiteration. So just if you see it, that's what it is. I don't do that. I think it's obvious that if it's out here, it can also be in here. Okay. To me, that seems to be obviously true. So I don't think it needs to be like copy and pasted into each subproof before you can use it. But that is a thing that some logicians do. Just to, if you ever have another logic class elsewhere, or if you look this stuff up online, you might encounter that reiteration rule. That's what's going on there. But I don't do it. So in other words, before I could do an arrow out there, they would say, you have to line 4 copy line 1 into the subproof in line 3, and I'm just not feeling that. So do we have a left side match between line 1 and 3? We do. So that's going to unlock this. That gets B arrow C. That's arrow out 1 and 3. Cool. Now look, I got a new arrow. Not in parentheses. Does it have a left side match? It sure does. Right there. What's that going to unlock? The C. Which, by the way, this is the thing we were after in the moment anyway. So watch, this one, even though it's a side quest, inside the main quest, or again, like a subproof inside a regular proof, everything here is just going to unlock. Now, it's just going to go boom, 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 and everything's done. Like, as soon as I write the C here, watch. So look, C. Arrow out. Where was the arrow that we just used? Line 4. Okay. Line 4. Where was its left side match? Line 2. And here's what I mean. Look, we started out, we were on a quest that when we provisionally assumed A, we were after C. That happened, which means we can zoom out now and say, yes, it is true. If you start with A, you will get C, as we set out on a quest to do here. Okay, what did we do here? We stuck an arrow between line 3 and ultimately line 5. Now, hey, look, but we got A. We said earlier that we were plugging in B to get A arrow C. Did it happen? Yeah, it just did in line 6. So this side quest is actually now complete because the one inside it is complete. But watch this, to say this one, so this side quest was done, so we can zoom out and say back into the main quest, hey, if you have B, then it leads to this other thing, namely A arrow C. Oh, by the way, that's the goal that we're solving for. It all worked out in the end. What move did we do here? We did an arrow in. Where did we start by provisionally assuming the left side? Line 2. Where did it end? Line 6. And so now this proof is also done.
So having introduced conditional proof, what we're going to do in the next video is we're going to take a look at translations that have conditionals and conjunctions in them. See you next time.